Hi dear students, welcome to the next topic from units and dimensions, which is called screw gauge. Last class we have learned about something called vernier caliper, and screw gauge is also another device like vernier caliper. Those who have not very much cleared about vernier caliper, please try to watch those videos again and make the concept is very clear. If you clearly understood vernier caliper, then only you will understand screw gauge. Without understanding vernier caliper, it's hard to learn screw gauge topic. Okay, because there are a lot of similarities, lot of connections are between these two areas. So let's move to our topic without wasting the time, and which is called screw gauge. So like vernier caliper, screw gauge is also a device and which is used to measure the distance or the length or the diameter, whatever, so or the thickness of some materials with utmost accuracy. As I told in the vernier caliper session also, the vernier caliper device is also used to measure thickness or the diameter or the length of some cylinder or any other measuring parameters of a device, of an item which is related to length with utmost accuracy. That purpose we make use of vernier caliper. The same case is applicable here also. Screw gauge is also another version of vernier caliper. It's not a it is entirely another device actually. Okay, so the purpose of screw gauge and the purpose of vernier caliper is also same. We can measure something with respect to a scale, as I told before in the last class, with the maximum precision, with the maximum accuracy. If I want to measure something, I need vernier caliper or I can use screw gauge. Both are actually serving the same purpose only. Okay, so what are the things we have learned about in vernier caliper? We will just recollect those terms. Hope you remember such terms, right? What are the terms we have learned? One is called least count. Okay, this is the main factor. Least count is MSD into 1 minus M by N. That is what we have learned about least count in vernier caliper. M is the number of divisions in the main scale and N is the number of divisions in the vernier scale. Then we have learned about how to measure the reading of an item. The reading of an item using vernier caliper. MSR plus VSR, main scale reading plus vernier scale reading, which is also equal to MSR plus least count into vernier scale division. These are the two concepts which we have learned in the last sessions from vernier caliper. Same cases, same item is applicable here also, because this device is also similar to the purpose. The aim of this device is also similar to vernier caliper. This device is also used to measure diameter, thickness, length or height of some devices with respect to in terms of accuracy. With utmost accuracy, this device will also help us to do the same. Okay, so screw gauge. So the first point, screw gauge is a device. So write down, is a device used to measure the diameter, length, etc. of an item. So this is also similar to what we have learned in vernier caliper. This is also used to measure diameter, length of an device. So here we are going to learn about how the device, what is the constructions of the device, how it's look like. In vernier caliper also we have learned about the constructions, right? Construction in the sense just like how the device will be look like. In vernier caliper we have learned it has some main scale, it has vernier scale, it has two jaws are there. Between the two jaws we are connecting the item in which we want to measure. So same way something is extra will be here also. Here I roughly do the diagram how the device is looks like. Okay, so this device is look like this, and a rough pictorial representations I can give it over here. Okay, so the devices look like this. Okay, here what we want to mainly understand is that the points I'll tell you. Okay, what we really want to understand from here is like this is as I told, this is also a device which is used to measure the length or diameter, etc. Here the parts of this one, this is like just a connector only, nothing else. This is like a screw. Okay, you have to imagine this is like a screw, and this screw which can be going and this is like a thread. Okay, how you can measure like a suppose in a wall you are putting a screw and suppose this is a screw, so you are tightening the screw like this. You are turning the screw, means the screw will go to wall. If you are turning in other direction, means what will happen, the screw will come out. The same way this is like your something called you can turn it like this and this will be coming out, and here there are some scale reading will be there, and if you are turning back, this knob will come here, and if you're turning back, this knob or this is something called screw, and this screw will going into this bigger area, and if you're turning on right side, what will happen, this screw will come out. So it is just like a screw. If you're turning in, it will come in this direction. If you are turning in other direction, what will happen, it will come inside like this. So this is like a screw, and here one scale will be there, and this scale is called pitch scale. Okay, the name is important. This is called pitch scale. This is similar to our main scale. Whatever I am writing in the bracket is similar to the one what we have learned in vernier scale. So this is similar to our main scale in vernier caliper. And we have something called a circular scale. We have something called a circular scale. The circular scale is similar to our vernier scale in vernier caliper. Our vernier scale in vernier caliper. This screw is also called spindle. This screw is also called a spindle, and this is also called anvil. So that is not important, but for us these two terms are important. One is called pitch scale, which is also called main scale. Another one is called circular scale, which is called vernier scale. Okay, and we have screw or also called spindle. Now what we are going to do, as I told before, while looking to the diagram, the main purpose is like if you are making this to be loose, what will happen, this screw will going inside it to this bigger area, to this vernier scale, to the circular scale area. Here I am using circular scale and pitch scale. In vernier caliber I am using main scale and vernier scale. Okay, so if I am making this to be loose, if I am making this to be loose, means this screw will going inside this circular scale. But if I am tightening the circular scale, this way I can tighten it. If I am tightening this one, this will come out slowly. Okay, now this is something called the construction. Next, we want to learn about two terms, major two terms will be here. One is called the first term is called pitch. So what is actually mean by pitch? Pitch means, listen very carefully, this area alone I am going to draw will be here. This area, this alone, for just for to have a better clarity, I am just drawing that area will be this area alone I am drawing here. Okay, so let me make it little bigger. So this is like, as I told, this is like a screw. So this is like a screw, this is like a screw. So we are going to learn one term is called pitch. You can write down on your notebook, pause the video and write a pitch heading. What is called pitch? Pitch means the distance between the two threads. This distance is called pitch. So pitch is something but the distance between the two threads is called pitch. So I can write it is the distance between two threads. Distance between two threads is called pitch. This is my first point. Okay, so this is distance between the two thread. If we have two threads, so one pitch, two pitch, three pitch, four pitch, like that. So that is called pitch. Next, one constructional property of this screw gauge is like, if you have done if you have done a complete full rotation, of circular scale, then what will happen means the screw will going inside or outside of the circular scale by one thread distance, which means one pitch. Okay, so which means if you have given a full round of tightening of this circular scale, then this much area is called pitch. That pitch area will going out. Or if you're completely losing the circular scale, then this much area will going inside two way. If you're tightening means this will come out. If you are making loose means this will come inside. So for one complete rotation, what will happen? One pitch distance area of the screw either will come out or will come inside. So pitch, I can say it is the another definition. It's a distance between the two thread I told. In another way, it is the distance. It is the distance covered by. It's a distance covered by. It's a distance covered by, what is this called? Spindle. It is a distance covered by the spindle for a full rotation of, means one rotation, a full rotation of circular scale. A full rotation of circular scale. Correct. If you are doing one full rotations, what will happen? The screw, one pitch will come out or one pitch will go inside, depends upon the direction in which you are turning the circular scale. So pitch is nothing but the distance between the adjacent threads, or I can say for one full rotation, how much the screws coming out or how much the screws are coming inside. That piece of length is called, that piece of length is equal to actually pitch. That is a design of these devices, and that is called the definition of pitch. Hope you understood this one, right? We are going to learn about the next term is called least count. Least count. Okay, what is called least count? Least count, as I told in the last class, it is the minimum length which can be used to measure the device. As I told, with respect to, if you have a centimeter scale with us, then I can measure 1 centimeter, 1.1, 1.2, 1.3, 1.4. Suppose if the correct length is 1.34, then is it possible to measure with that scale? Not possible, right? 1.34. Either I can measure 1.3 or I can measure 1.4, but I cannot measure 1.3. In that cases, what we'll do? We will use either vernier caliper or screw gauge, so that which will give you a correct value either at 1.34 or 1.34 value. Either this device will give, either it is vernier caliper or it is screw gauge. Both will be the same use case. Okay, so to measure this one, we need to know the least count will be here. So how we have measured the least count? Least count means here for one division. Here one division is normally 1 millimeter in screw gauge. Normally there are different screw gauges are available, but ideal cases in a normal one, this distance, which is called a pitch, that pitch is 1 millimeter distance. And here there are I don't know, this year you will get a chance to see this screw gauges in your lab. If in case you will get a chance, just explore that one. There is one thing will be there, the screw gauge circular scale. If you turn it, it contains 100 divisions. Like suppose this is your circular scale, and if you are going to turn, first time you are going to turn, then it will be like this, tick 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 tick, like that. So which means 100 tick sounds you can hear from the devices. 100 tick means the measurement inside this one, which means 100 divisions are there within the circular scale. 100. So if you have covered full rotation, means you are covering 100 ticks, means 100 divisions you are covering. So this is a pitch, this is the number of divisions in the circular scale. So least count means the least count LC will be equal to pitch. pitch divided by number of division. Number of division in where? Number of division in pitch scale or circular scale? Number of divisions in circular scale. Number of divisions in circular scale. This is called least count. Okay, we'll understand little more about this least count. Okay, we'll learn about a little more about this least count. Okay, so which means as I told, normally one pitch equal to 1 millimeter. Number of divisions, number of circular scale division, CSD. There we have written VSD, vernier scale divisions in vernier caliper. So how many divisions as I told here? 100. So the least count equal to pitch divided by number of divisions in the circular scale. 1 millimeter by 100, which means 0.01 millimeter. So with this much accuracy, I can measure the length or diameter of an item which is going to measure using screw gauge. So screw gauge, actually here we will place the item to be measured. Okay, here we will place the item to be measured, and if it is bigger means I have to make this screw to be loose, and if it is smaller means I have to tighten it. So this will be fit with this one, fit with this anvil and this spindle. So this length will, this item will split between these two areas, and it will be, and we can measure the length. How we are measuring that I will tell you. Now we are at a least count. Least count means with this accuracy, a 1.01, 1.02, 1.03 I can measure. Okay, as I told, in case of an this is in terms of not meter, millimeter, because the numerator is millimeter, right? So 0.01 millimeter. As I told in the last sessions and the beginning of the session also, with any scale we can measure 1.1, 1.2, 1.3, 1.4. So between 1.3 and 1.4 we have 1.34. That is not possible to measure, but it is possible to measure with the help of screw gauge and vernier caliper, because 2 digits after decimal, 2-digit accuracy it is giving. That is the importance of vernier caliper or screw gauge. Okay, so this is something called a least count. Next we are going to see how we can measure, how we are going to do the readings with this screw gauge. Okay, so write on the next heading, reading with screw gauge. How we are going to read. So the next heading is reading with screw gauge. So reading with screw gauge. Reading with respect to screw gauge. How we will read it? Have you remember how we have read it in vernier caliper? We have read it in vernier caliper with the help of MSR reading plus main scale reading. Here instead of main scale what is coming? Pitch scale. Main scale reading plus least count into number of divisions. Number of divisions in vernier scale. So let me write what we have learned it in vernier caliper. In vernier caliper we have learned main scale reading plus vernier scale reading. This is what we have learned. There we have written main scale reading plus least count into vernier scale division. This is what we have learned. When come to screw gauge, the same principle is applicable. Main scale readings, instead of main scale reading, what will say? Pitch scale reading. Pitch scale reading plus least count into circular scale division instead of vernier scale divisions. This is called circular scale division. So pitch scale reading plus least count into circular scale reading. This is what we are going to see will be here in case of a screw gauge. So we have vernier scale, we have a screw gauge, and pitch scale reading plus least count into circular scale reading. Okay, so we will see how we can, this is a formula we have learned, but practically how it is going to measures we will see. Okay, so let me take this diagram as an example. So I am just clearing the terms. So we know the pitch scale, we know everything. I'll make it to be a bigger diagrams with some informations behind this one. So this is a connections, and we have a screw connections are like this, and we have it, our circular scale is like this. Let me make it bigger, and we have a connection like this. Okay, so we have a connection like this. Suppose, just assume I have placed one wooden block will be here. I want to measure the length of this blue color wooden block. This is my wooden block. How we will measure this wooden block? Okay, so wooden block will be measuring here. This line is actually a zero line of this line is actually a zero line of circular scale. So up to this we will measure the reading. For example, here it is first reading like this. Then okay, so this is the 0th one, and here the first one, and here the second one. That's all. Okay, in between we have small readings are available. But here we have two things. So as I told, this is called pitch scale reading. So what is a pitch scale reading will be here? So if I am making more tight, means more areas will come. Now this is a scale, but if I am adjusting it either back and forth, and I am making this wooden block in a tight position between the anvil and between the spindle, then before reaching this zero line of circular scale, what I will see, I can see 2 millimeter. So PSR reading is 2 millimeter. Okay, so after adjusting, so to come out this screw, to tighten the wooden block, what I will do, I will rotate this circular scale. So if I rotate the circular scale, as I told, circular scale will have how many divisions? 100 divisions are there. Suppose if I have rotated this one, if I rotated here also one line is called, that is called baseline. Here also one line is called baseline. So if you are rotated, so initially this baseline is coincide with the zero line of circular scale. Now after I am tightening this one, the baseline is come up with a position. Here we have many readings are available. So I have tightened it. And at some point maybe the reading will be 30 will be here, and 40 will be here, 50 will be here, 20 will be here, 10 will be there, and other numbers are on the back side. Okay, because it's a circular one, right? So one side we can see, other side is on the back side. So here I look into least count. Least count I have already calculated. Least count will be equal to pitch divided by number of scale division, which is 0.01. Now we have circular scale divisions. So PSR we are substituting here 2 millimeter plus least count I measured 0.01 into circular scale division. How many divisions will be? 10, 20, 30. So 30 is the one which is coming with the baseline. So that is the number of divisions. So 30 is the number of division. If you solve this one, you will get the thickness, the exact wooden block thickness. We will solve it. We know everything is in millimeter, so I am writing not millimeter. So 2 plus. Okay, 30 we are multiplying, so we can 0.3. So the answer is 2.3 millimeter is the thickness of this wooden block. Sometimes you will get 2.32, 2.34, 2.35, doesn't matter, but here I am assuming it is coincide with the 30. It may be 32, 33, 34, 35, any number. Just an example, I have taken 30. Then that is called circular divisions. Okay, so you will always start when this anvil, this is called anvil, when this is anvil and spindles are in touch. What will happen? Baseline is coincide with the 0th line of circular scale divisions. Whenever you are make it to be loose, to place this wooden block, these divisions will changes accordingly, and the reading will also changing accordingly. So circular this screw gauge reading is equal to pitch scale reading plus least count into circular scale reading. This is actually the reading with the screw gauge. Okay, so we have learned pitch. What we have learned, pitch, the distance between the two screws, two threads, or it is also called the one full rotation, how much area distance covered by the spindle or the screw, that is called a pitch. We have learned about least count, we have learned about if I get a screw gauge, if you want to measure something, please give me, I will give a measurement. We know how to measure with the help of a screw gauge also. This is a concept which is available with screw gauge. There are two things will be there extra. Okay. The next topic is errors in screw gauge. Okay. Every device is manufactured by some company, right? Every device, whatever we have seen, even our mobile phones, our laptops, our computers, even our light bulb, fan, everything will have a company. Similarly, screw gauge will be manufactured by different companies. When they are manufacturing, there are chances of defects. Okay, defect means issues or problems or incorrections. For example, I'll tell you one example. You have your mobile phones. Okay, we all of you are using mobile phones. So at some point of time, if you have brought one mobile phone and your touch screen is not working, you will say some complaint will be there, right? So same way, there are chances of getting complaint. A very common complaint which is coming in a screw gauge is called, you can see in the board, positive error and negative error. It's very simple. What is actually a correct screw gauge? If you're going to buy some screw gauge, then what is the error you can see it, or how you can take a good screw gauge, which means you have a baseline will be there. Okay, as I told before, you have a baseline. If this baseline must coincide with the zero line, the baseline, if you have completely tightened it and your spindle and your avin are in connection, you are not placing any wooden block or any item in between to measure these things in a normal condition. You are not measuring anything, you have just tightened it and both are in touch. During that conditions, the baseline should coincide with the zero line. Then we can say there is no error. There is no error. Such conditions. Okay, this no error conditions. This no error condition, that is called zero error. That is called zero error. What this means? What this means baseline coincide with. Baseline coincide with this baselines coincide with zero of circular scale. Baseline coincide with the zero of circular scale, then it is called zero error. Sometimes if you are make it tight and you have seen the zero is not reaching the baseline, zero is below the baseline, then that is called positive error. You have some positive number, right? Always you are counting from zero towards up, so you have some extra will be here. Then this screw gauge is not the correct screw gauge. The screw gauge will have some defect or some problem. That is called positive error. In another way, if you have tightened it and you have seen the zero is above this one, zero is above the baseline, then this type of screw gauge will have a defect of negative error. Negative error problem will be there. So if somebody will be say, oh, this screw gauge is not correct, it has negative error issue. What is negative error issue? Means the zero is not aligned with this baseline, zero is above the baseline, and here in case of positive error, zero is below the baseline. So two types of errors are normally coming, positive error and negative error. While we are purchasing some screw gauge for our use cases, then what we have to ensure, it is not contains any error, which is also called zero error, which means the baseline should coincide with the zeroth line. That is the correct device with no error, with no defect, which can be used to measure. Okay, so this is the errors from a screw gauge. Hope you understood today's sessions, and with this one we are come to the end of this chapter, units and dimension. So study and all the best for the questions which are coming from these sessions. So thank you very much. Bye bye.